Alright, so we have introduced so many different laws which can be used to help rewrite the query expressions, and which may result in better queries for most of the time. Actually, we can also have some other rules or heuristics which can be used for rewriting the queries, and we can show you with two rules in this page. So normally, if we do the rewriting of the queries based on the laws we showed before, in most of cases we can get some better results and better queries. And some other rules or heuristic we can use here is showing according to the page. The first heuristic we can use is called the push selection down. We can push the selection down on the logical plan or the logical trees for execution of the queries. And this is one of the heuristics. And some other cases, sometimes we can push the selection up first and then down. This is another heuristic we can use for redesigning or rewriting the query expression logical trees. What does this mean? We can show you with some examples. Let's assume we have a query logical plan or logical tree in this page, and we are doing the query based on two relations, product and the complaint. And between them, the logical tree will be like this. The first operator we use is to joins. We join these two relations together according to the maker of the product and with the name of the complaint together. And then we're going to do the selection. We want to select the product whose price is larger than $100, and the complaint city is in Tallahassee. And finally, we're going to do one projection to project the product name as a result. So you can see this operation as well as the logical plans, right? So we're working on two relations. We'll do the join first and do selection and do the projection. So it really depends. If this product relation and the complaint relation, their size is very small, and join, this kind of operator IO cost is very low. If so, then this kind of logical tree will be very good, right? Because the cost for every operation will be very low, right? However, sometimes if this product relation as well as complaint relation is very large in terms of both tuples as well as attributes, then we compute the joins between them will be very costly, right? Because they have so many attributes, so many tuples, and if we do the joins between them, it will be very costly. Then we can push this selection down on this tree. We can push the selection to the down layer below the joins. So what does this mean? So actually, according to the condition, we have two conditions. Right? The first one is the price is larger than 100. The price is attribute from the product relation. Right? The second one is city is in Tallahassee. The city is attributed from complaint. We can push the selection operation down. So we have this price larger than 100 for the product relation, and city equals to Tallahassee for the complaint relation. And we can rewrite or redesign the logical tree on the right-hand side instead. So given two relations, product and complaint, we can design one selection operator, which is price is larger than $100. We want to find the product whose price is larger than $100, right? And we can also get the complaint whose city is in the Tallahassee, right? And then we can join them together according to the maker as well as the name of the complaint. Furthermore, we can do one projection of the product name, right? So compare with the left-hand side, the right-hand side will be very different because we push the selection downward, right? We do the selection first on product as well as complaint separately, and then we can do the joins, and then we can do the projection. So it really depends on the relation, right? For sometimes, if we have so many tuples and so many attributes, this kind of the way to do selection first will be reduce the cost a lot, right? And it will be a very good design policy. Okay, so you can consider this. It really depends on the cases, right? Sometimes this one can be very efficient and effective, and sometimes this kind of operation will also introduce more cost, right? Because we have to store the intermediate result generated by the operations. It really depends on the cases. Okay, so these are the heuristic rules we can use for redesign the expressions or the logical trees for the queries.